functions like we do a lot of other data types to the extent that we're able to pass them into functions, but then also return them out of functions as well. Today we're building on that principle by talking about something called closure, which is a pretty powerful concept if you want to kind of drill down into it. The lesson itself is pretty short, so there'll definitely be a lot of time for the workshop for today. All right, so let's get underway here. So basically, the idea of closure is building up on this idea that not only can we pass functions into functions, but we can return functions out of other functions, which hopefully should make sense because we already saw that how if you can take a function, store it in a variable, and pass it in, there's no reason why we can't like give it back, right, or output it again. But more important than that, we're talking about this idea of closure, which actually allows us to kind of not circumvent necessarily, but it does give us a way to kind of play around with the idea of scope. So hopefully this is very clear. Here on line 3 through 5, we have a function called returns a string that just returns a string. And so when we invoke that function on line 7, notice how the open and close parentheses is the only way that we can invoke a function in JavaScript. Once we invoke it, that function is going to return a string, which we then store under return value. So we get back I am a string for the value of return value. Now, if I was to kind of go along with this idea that that functions are like any other data types in JavaScript, well, here I have a function called greetMe, and on line 5 I create a function called getGreeter. Okay, notice how up until line 7 here, on line 6 I'm returning greetMe, but more importantly, notice how greetMe is not treated as a function, right? It's just a variable. And the reason why I know that is because there's no open and close parentheses after greetMe. I'm not invoking greetMe. All I'm doing is treating it as a variable. So as far as I know, greetMe could be anything. It could be a number, a boolean, or a string. And so we're not saying, hey, greetMe, why don't you go execute and give us something back? It's just saying, hey, whatever you are, let's just return it. Okay. Also, notice how as up until this point in the slide, on lines 1 through 3, I've defined the function greetMe. On lines 5 through 7, I've defined the function getGreeter, but at no point have I actually declared, or sorry, at no point have I actually invoked any functions yet. Okay, and so here's where it's once again really important for us to make a distinction between treating a variable as a variable versus treating a function as a variable versus invoking the function. Now on line 9, here's the first instance on the right hand of the equal sign where we actually invoke getGreeter. Okay. And so if I just kind of step through this line by line, what happens when I invoke getGreeter? getGreeter takes me to line 5, which takes me to line 6, and line 6 says return greetMe. And that's pretty much it, right? Now, this is a quick recap, and we'll talk about this again in a few slides, but if you remember how scope works is whenever you use a variable, JavaScript will look in the nearest scope first and look for that variable. In this case, it will look in the getGreeter function and look for the greetMe variable. And it's going to say, hey, it's not there. So then it will say, okay, well, let's look in your parent scope. In this case, the parent scope for the getGreeter function is the global or the window scope. And so do we see a variable called greetMe there? Yep, it's a function we made on lines 1 through 3. And so on line 9, getGreeter, after we invoke it, it just returns the function greetMe from line 6. Up until this point, we still have not yet invoked greetMe, right? We've invoked getGreeter, which returned the greetMe function, but we have not invoked greetMe yet. And in fact, on line 9, this basically boils down to let greeter equal the greetMe function. And so if I console log out type of greeter, and when I console log out greeter, and on line 13 when I actually invoke greeter, I get back the following, right? Type of greeter, it's a function because it's a greetMe function. On line 12, console.log, ignore the way the printout makes it look like it's an array. It's not an array, it's just the way that JavaScript prints out functions. But essentially this is telling you that greeter is the greetMe function at this point in time. And then lastly, if we know that greeter is a greetMe function at this point in time, then when we invoke greeter, it's the same as us invoking greetMe, and we console log out hi. Everyone good so far? Right? The biggest thing we want to be wary of here is just to make sure that on line 9, when we return getGreeter, we don't invoke greetMe. We only invoke greetMe by invoking greeter on line 13. And so just always keep your mind, are we treating the function as a variable, or are we actually invoking the function? Okay, so let's take a look at a few more examples here. So here we have our same greet me function. On line 5, we still have our getGreeter function, but here on line 6, notice how we're returning greet me, but now there's an open and closed parentheses after it, which means we are invoking greet me. Okay. Once again, it's important to note, up until line 8 at this point on this page so far, we have not invoked any of the functions on the page yet, right? We've declared greet me, we've declared getGreeter, but we haven't invoked them yet. Sorry, I kind of have a cough too, so I apologize if I cough every now and then. Okay, so now on line 9, we see the same code we saw last time. On the right-hand side, we're invoking getGreeter. But now when we invoke getGreeter, what does it do? Well, now it returns the greetme invoked, or rather, we invoke greetme and we return what that returns. So then line 6 takes us now to line 1, because in order for us to finish line 6, we have to finish invoking the greetme function. And so when we invoke the greetme function on line 2, we do a console.log of hi. But then what does the greetme function actually return? And the answer is, and this is something that you'll see quite a bit of, right? In JavaScript, every function has to return something. And if you don't tell a function what to return, then by default it will return undefined. And so for the greetme function here, even though we console log out hi, we didn't tell the function explicitly to return something, and therefore this function is going to return undefined, and the undefined gets returned to where we called it, which was on line 6. Okay, and so therefore line 6 becomes return undefined, and that undefined gets returned then to line 9, and so essentially line 9 boils down to let greeter equal undefined. And so now when I console.log out type of greeter, we console log out greeter, and we invoke greeter, we get back the hi comes from us invoking greetme on line 6 there. But then if I do type of greeter, I get back undefined. If I console log out greeter, I get back undefined. And then lastly, when I try to invoke greeter, I get an error because I cannot invoke undefined, or rather, as the error says here, greeter is not a function because it's undefined, right? And so now not only are we returning functions, but we need to be careful about whether we're returning a function, about whether or not we're returning a function once we invoke it, and also what does a function return, right? Is it returning a value? In this case, it's not, so we know by default it's returning undefined, but that's just something we need to be really careful about going forward. Everyone so good so far? Yay, nay? Looking good. Great. Awesome. So once that idea makes sense, then we can actually play around with this quite a bit, right? Here is the same exact code as the previous 2 slides, except the only kind of new creative thing we're doing here is we have this function called getGreeter, and then within it, on lines 3 through 5, we create a function called greetme, and then on line 7, we return the function greetme. So here on line 10, when I say let greeter equal getGreeter, well, when we invoke getGreeter, it takes me to line 2, then line 3 through 5, in which case I create this function called greetme. I go to line 7, which returns the greetme function, and that returns it back to line 10, and so let greeter equal the greetme function. And so when I invoke it, I see the same thing I saw on the very first slide, right? So this just kind of highlights the fact that like we can actually return a function anywhere as long as we've properly created it beforehand. And then last but not least, and this is where the arrow function comes in, but I can actually just fix this too so we don't need to use the arrow function. All this is trying to say is that, hey look, we can also return anonymous functions too, right? And remember, anonymous functions are just like any other functions, except the idea is that we return them and we don't need to recall them, we don't need to store them in a variable name going forward, right? So whether or not we use an arrow function here is irrelevant, because fundamentally all we're saying is, hey, let's create a function and return it right away. And in this case, we do it on line 8 when we invoke getGreeter. We're going through getGreeter, takes me to lines 2. On line 3, I return this function on lines 3 through 5. And so on line 8, that becomes let greeter equal this anonymous function. And then when we invoke greeter function, it's the same as us invoking the anonymous function too. Yes?
Do you actually need to store
Well, so that's a good question. The thing is that if I just do, like, if I get rid of greeter, I just do get greeter parens. This does return a function for me, but then the idea is I don't have anything to call it going forward, right? So this returns a function, but then because I don't store it anywhere, I can't use it later, right? So let's say this returns the anonymous function here. Here, now if I go to line 9, how would I call the anonymous function that got returned? Right. So I mean, the analogy that I usually give here with regards to kind of storing return values, right? It's like this. It's like someone hands you something, and then they let go, but you don't put your hands out, like you don't catch it, and so it's almost like you didn't get anything out of the exchange. Um, One thing that we're going to talk about, I think near the one of the very last lessons, actually maybe sooner than that, is the idea that one thing we can do is something like this. Like this is totally valid JavaScript because all we're going to do is remember the way we chain things together is we invoke this, then we invoke this, and then we go from left to right, and then we invoke all of this. So this totally works. But usually it's just not good practice. This is better practice because there's also this idea that you don't want to invoke this maybe more than once either. But all that is to say that, like, regardless of what happens, you want to make sure that you're capturing the output of getGreeter somewhere if you intend to use that output later on.
Got it. Thank you.
Yep. Cool. Okay. So then this slide, honestly, it's the exact same as the previous slide. The only difference here we want to be aware of is obviously functions take in parameters, and so whenever we return a function, well, we just want to make sure that that function that also does or does not take in a parameter, right? So here we have our getGreeter function, and then we return the anonymous function, which takes in the parameter called name. And so then on line 8, when we invoke getGreeter, what we do is we return a function that takes in a name. And so when I do invoke that function later, on, in this case, I'm passing in Marie as a name because it expects a parameter. It's also pretty straightforward there, I think. And then that kind of wraps up this segment on just the idea of returning functions from other functions. And then we can talk about closure. But I guess before we do that, is there any question so far on anything I've covered with regards to returning functions from other functions? Any questions at all? I will wait 15 more seconds just in case. Cool. All right. So let's move on then. So before we talk about closure, let's just kind of go back and recap through really quickly how scope works. Essentially, the idea of scope is that if I give you a variable, then by default JavaScript will look in the nearest set of curly braces first because that's the nearest scope. If it doesn't find it in that scope, it will look one level out into the next set of curly braces, which we call the parent scope, and so on and so forth, all the way until it gets to the global scope, which is the outermost level. And then if it doesn't find it, then you'll get the reference error that we've seen, which is that this variable does not exist. Remember that closure and therefore scope, remember that scope, it only looks outwards. It doesn't look inwards, right? Which means that you can't look in the scope of a function that's already inside of you, right? And so the idea is that you can look in your parent scope only, but you can't look in your child scope, or in other cases in your sibling scope. So, and sibling scope just means the scope of a function that's at the same scope as you, right? So if I have two functions on the page and one has a variable inside of it, the other function cannot look inside the other functions, or the other function cannot look inside the first function's variables. So here, when I invoke the says hi function on line 9 there, it console logs out hi name. And so then when I look for name, I try to look in the says hi function scope first, which is between lines 8 through 10. I don't see a variable called name. So I say, great, let me look at my parent scope, which in this case is a greeter function between lines 6 through 12. Is there a function? Sorry, is there a variable called name in there? There is on line 7. So then I use that and I console log out hi Marie. Okay, so that's a really quick refresher on scope. Hopefully it's coming back to everyone. But let's talk about how now we can talk about how closure actually is kind of a twist on scope. Closure is this idea that the inner function can access the values defined in the outer function even after the outer function is finished running. Okay, so that's a lot of words and sometimes it's not quite clear. So we'll run through a few examples and then I'll kind of come back and try to wrap up that idea one more time. Okay, so here if I have a function called getGreeter, when I run it, a few things are going to happen. The first thing it's going to do is console log out getGreeter is running. The second thing it's going to do is create a variable called name. The third thing is going to console log out getGreeter is finishing, and then on line 8 there it's going to return this anonymous function, in which case all that function does is console log out hi comma the variable name. Okay, now if I invoke getGreeter here, line 2, 4, 6, and 8 through 10 are all going to happen. And most importantly, on line 8, I return a function, an anonymous function that then gets stored in greeter. Okay? And then on line 14, I am going to invoke that anonymous function. Now, if I look at the way that the history is running, right? On line 13, when I invoke getGreeter, line 2 prints out getGreeter is running, line 6 prints out getGreeter is finishing, line 8 returns the function. So far, so good. And then when I invoke the anonymous function console log out hi name on line 14 there, right? When I invoke greeter, it prints out hi Marie. Okay. Now, on the surface, this looks perfectly normal and nothing special is going on. But if we just pause and think about it for a second here, something actually that's a bit abnormal is going on, right? On line 14 there, I am invoking the function greeter. And greeter is making use of a variable called name. But the problem is, on line 14, I don't have access to the variable name, right? Because on line 14, when I think about the scope that I'm in and the variables I have access to, I have access to the function getGreeter, I have access to the greeter variable, but I can't look inside the scope of the greeter function. And so therefore, I can't look inside line 4. And so here's where this idea of closure comes in. It's this idea that even though in this case we're outside of the function getGreeter, we actually have a function, in this case greeter, that is able to access variables that are inside getGreeter. And so when we say closure, the idea, or I guess what the semantics of it implies, that we're actually enclosing our scope around the variables that were available to us when we were created, or rather when the function was created, right? Putting it more succinctly, this just means that the scope of a function will always and permanently be tied to where the function was created, not where it is being used. Okay, and so I'll say one more time. The scope of a function is based on where it was created, not on where it is being used. And so this anonymous function on lines 8 through 10, when that function was created, it had access to the scope between lines 1 through 11. And therefore, no matter where we use that anonymous function, we will still always have access to that scope. And that's why even though we're using the anonymous function on line 14, which is outside of the getGreeter function, we still have access through that function, and only through that function do we still have access to the variables that were created inside the getGreeter scope. I'll let that sink in for a little bit, just to ever have time to process it. But does that make sense? Or does anyone have any questions that jump out right away at them? Okay, I think that's a good sign. Don't worry, we'll do a few more examples of these. Okay, so here it's an example that looks very similar to the previous one, except now notice how I put in a parameter called name, right? And so on lines 2 through 7, I create this function called getGreeter that takes in a parameter called name. And so on line 9, when I say let's invoke getGreeter, and I pass in Rosalind as the name, on line 3 there, I've added this comment that essentially tells you, hey, Adding in the Rosalind as a name parameter is the same as creating a variable called name inside the getGreeter scope, and in this case we're assigning it the value of Rosalind. We return the anonymous function on lines 4 through 6 and we store it in greeter. And once again now, when I invoke greeter, it's the same as me invoking the anonymous function. And when I invoke the anonymous function, I'm console logging out hi name. And so that anonymous function is going to say, okay, in my own function scope between lines 4 through 6, I don't have a variable named name. But let me look in my parent scope. And what is my parent scope? My parent scope is based on where my function was created, not on where it is used. And so therefore the function scope for the anonymous function, the parent scope for that anonymous function is the getGreeter function on lines between lines 2 through 7. And so look through 2 through 7. It says, do you have a variable called name? And we do. It's called Rosalind, and therefore that's why we print out hi Rosalind.
Hey, David.
Yep.
There are 2 slashes in front of that name, so
that just means it's common, and I put it there just for illustrative purposes. So we just
but it's part of the code.
Yeah, but JavaScript skips comments, and so that's for human consumption only. The computer, when it sees it,
Well, technically, the code that you wrote did not assign Rosalind to name.
Yep, you're right. So generically speaking, getGreeter does not assign any value to it. We only assign it because here on line 8 we're invoking getGreeter,
Right.
passing in Rosalind.
Because of that line, it's because actually of line 8, right?
Yep, exactly. Okay, and so if we just do more examples of this now, hopefully at this point you kind of get the idea of closure, right? It's just, hey, when a function is checking a scope, normally speaking so far, we've always kind of created this function and then use it right away. So the question of where scope is hasn't been that big, right? You say, well, the function's there. I just keep looking outwards and outwards. But closure now basically says, okay, in order to properly understand where the scope of a function is, you actually need to figure out where the function was created and figure out what scopes it had access to at the point of creation. Okay, and so here's one more example. Once again, in this case, we have 2 parameters, one which is taken in by getGreeter, and then one which is taken in by the anonymous function. And all the anonymous function does is it console logs out hi name1 meet name2. And so on line 8 here, right, when we say let greeter equal getGreeter and we pass in Marie, well, Marie now becomes the variable for name1. And then we return this anonymous function into line 8, and then we store that anonymous function as the greeter function. And so now when I say greeter Rosalind, it basically says, hi Marie, meet Rosalind, right? It takes in Rosalind as name 2 because that's what I invoke greeter, or therefore I invoke the anonymous function with Rosalind as name 2, so that makes sense. And then when it needs to find a name 1, it says, okay, well, I don't have a name 1 in my own scope between lines 3 through 5. Let me look in my parent scope. And once again, my parent scope is based on where I was created. And when the anonymous function was created, or in this case, created and then returned, the variable name1 was represented by Marie. And so therefore, it recognizes enough to say my scope is, or rather, my content is hi Marie, meet Rosalind. And then so here we actually see a very interesting pattern, right? So lines 1 through 5 is the exact same as the previous page. But now what we actually see is we can actually create different greeter functions, right? In this case, we store one of the greeter functions in this variable called introduce Marie2, where the variable name1 is stored as Marie. But right beneath it, we then invoke getGreeter again, and we're returning another anonymous function. But in this anonymous function's case, it thinks that name1 is Rosalind, and we store this anonymous function under introduce Rosalind2. And so here, if I invoke this function several times in a row, what I actually see is using this one almost like function template, I'm able to create different anonymous functions that think different names are name1. Right? And so it's actually a pretty kind of neat way for us to say, well, rather than making a function called introduce Marie2 in which we're hard coding what name1 is every time, let's just do it once, get back a function and that function almost like the way like baby chicks like imprint based on like what they see when they're created or who they first see when they're born. This is the same idea, right? Um, when these anonymous functions are being created, well, in their world, at the point of their creation, name one is x, and so therefore it is x. And that's pretty much all I had.
Hey, David?
Yes.
So, just to clarify, is introduce Marie to and introduce Rosalind to the anonymous function?
Yep, there are two different versions of the anonymous function.
Even if you actually used it as the variable to store get greeter.
I'm sorry?
But on line 7 and 8, didn't you use those functions to be the storage for get greeter?
I'm using introduce Marie to and introduce Rosalind to store the return value of getGreeter. And so getGreeter on line 7 returns the anonymous function. And to that anonymous function, name 1 is Marie. And then on line 8, I'm invoking getGreeter again, but now I'm returning another anonymous function. And to that anonymous function, name 1 is Rosalind.
Got it. Thank you.
Yep. And so that's why on lines 10 through 14, when I invoke each of those functions, each of those variables has a different kind of value as name 1. Because when they were created with different name 1 values. So yeah, I mean, you guys saw the next slide. I don't have anything else to talk about. So let me definitely know if you have any questions on this topic. But this is pretty much it for closure, right? Once again, it's just a relatively simple idea that the scope of a function is based on where it is created, not on where it is being used. And so therefore, when you use functions, don't take it for granted that just because where it is on the page, that means where its scope either starts or ends. Cool. All right, last call for questions before we get started on the workshop today.